Welcome to another episode of Just One More Fix. This is James. With me in this episode is Lacey.
Hey.
You can find us online at justonemorefix.com or on Twitter at justonemorefix. If you like us, head over to iTunes or to Google Play and give us a rating and a comment. In this episode, we're going to talk about CRISPR, gene editing in your RPGs. And now, it's time to get our gaming fix.
I'm Lindsay,
I'm Austin.
And I'm Joe from PopXcast.
a podcast member of the Gonna Geek Network.
Just like the show you're listening to now.
The opinions expressed are those of each individual host.
Check out all the other podcasts at GonnaGeekNetwork.com.
And get ready because geekiness begins in
3,
2,
1.
Welcome to Just One More Fix. Couple quick announcements today. First off, our content on Patreon continues to grow, and we mentioned in our last episode that Lacey was working on her Dread project, and that Kurt is working towards scanning his maps and getting all of that put together so that we can get that uploaded to Patreon. So if you guys are interested in also getting some bonus content and some of our tools and things and stories that we tell at our table, you can go to patreon.com/justonemorefix and support us there. You'll also get access to all of our raw feeds and our pre and post shows, as well as early access to some of our shows that kind of take a while to get put out in the release schedule and whatnot. Speaking of your Dread scenario and project, Lacey, do you have any update for us?
I would say that progress continues in more of a theoretical way and not so much in a literal fashion. So the character surveys are done. I have an image for puzzle creation, and I'm working on the plot, but it is a lot more work than previously anticipated.
Right. But
as it turns out, it takes not very much time to run that scenario and a lot more time to think about it and type it out and put it in a way that is going to make sense to somebody else reading it that isn't me just scrawling some random scribbly notes on the page.
Right. Yeah. So we want to make sure that you guys get something that's one, useful, and stands up to our quality standards, whatever that might be.
I guess if you want hard numbers, I'm through the introductory scene and through scene 1 of what's probably 5 scenes in a conclusion.
Right. Right. So just basically a scene map, trying to map things out for the scenes that are not guaranteed to happen, but most likely going to happen throughout the course of the game. And as I said, Kurt is working towards getting all of his stuff scanned, and that's pretty much easy. That's all. His stuff is all done. It just has to get scanned on a giant scanner, which I believe he has access to. So that should be coming soon. I think that's all of our announcements. So we're just going to jump right into this one.
So previously in our sci-fi discussion episode, we had talked about the meddling of mankind in order to create improvements and how a lot of sci-fi stories start off with that and then have this sort of moral, what's the word I'm thinking of? Not dilemma, but moral.
Ambiguity?
No, that's not it. Like reproach kind of. Anyway. We talked about how man is seeking to counteract nature and the things that happen as a result of that. And I feel like this episode directly ties into that idea because we're going to talk about CRISPR. And I'll let you kind of explain what that is. And then I think people will understand directly how that's relevant to that topic.
Right. So I'm going to give you guys the probably 2-minute meathead version of what CRISPR is. If you want a more precise explanation of it, just search CRISPR. It's CRISPR, or you can go to Radiolab, which is another podcast, and listen to their CRISPR episode, and they do a pretty good job of laying out what it is. So here's the 2-minute synopsis of what CRISPR is and kind of where it came from.
I'm timing you.
There were some scientists that were studying bacteria, and they realized that there were, in between the DNA strands of the bacteria, they found pieces of virus DNA. And basically, viruses and bacteria are mortal enemies, and they kill each other all day, every day. They say something like 50% of the bacteria in the world is killed by viruses and vice versa, and then they reproduce and replenish every single day. So they wondered, why is this virus DNA inside the bacteria? Well, as it turns out, it's one of the defense mechanisms that the bacteria has. So it releases these cells that look for specific DNA sequences that they know belong to viruses. And if it finds it, it basically goes and it looks for it, and when it sees it, it cuts the DNA off and kills the virus, basically, right?
Mm-hmm.
Now, the way it gets in there is as a bacteria encounters viruses, when it kills them and fights them off, it takes pieces of their DNA and puts it inside there to store it so that it can find it again in the future and have a exact copy to kill it, basically, okay?
So this is not entirely unlike what our body does when it's creating immunity to something. The difference being bacteria is a lot simpler, and its DNA is just stored basically in a circular chain just hanging out in this single cell organism. So the mechanism is significantly different, which is what we're actually interested in.
So CRISPR stands for, this is a great acronym, so you can throw it at your players if you want to. And this will be game relevant because we're going to take this idea, kind of explain it to you, and then draw it into an RPG scenarios and how to use it to
So for those of you
awesome.
who are English or history majors, please bear with us.
Right.
It's going to get better.
Right. So CRISPR stands for Clustered Regularly Interspersed Short Palindromic Repeats. So
Sounds fascinating.
Quite a mouthful, but you can just call it CRISPR and you sound cool. But so they noticed that in these DNA chains of the bacteria that there were these regularly repeating palindromes, which is where the name comes from. And then that led them to discover what they did. Now, they thought about, with the problems of antibiotics not working, that this might be a solution for antibiotics because it kills all these viruses. But it has to find a very specific gene. It's only looking for one gene sequence. So if you ever took a biology class, there's the TC and AG that match up. And if it's not those things, then it just leaves it alone. So basically, it just goes floating along. This CRISPR cell thing goes floating along. It finds a piece of DNA. It looks at it. And then it attaches to the DNA. It unwinds it. And if it matches the piece that it has, then it cuts it off. And if it doesn't match it, then it just goes on about its business. Okay. Now, the interesting thing about this is that they're going, in reality, and we're going to link to some articles and that kind of stuff where they're actually using this for human trials right now. So one of the things is there are certain diseases that are caused by genetics. They're genetic abnormalities or mutations that cause these defects. So there's a guy right now that has something, it's a very rare autoimmune disease called Hunter syndrome, and it's a genetic condition. So they're injecting him with these CRISPR cells that are programmed to find the gene that causes the autoimmune response for this Hunter syndrome, and it's going to cut it off. And then there's two different methods. One is they will inject you with the gene, like bombard you with the gene that is the good gene, the correct gene, the non-mutated gene. And there's enough of it free floating around that your body will pick it up and the ribosomes will kind of grab onto it and repair it, basically. Mm-hmm. Or the other potential is that it just sort of repairs itself, but it's in doing so, the gene is damaged and it sort of turns that gene off.
Right. And while Hunter syndrome is a rare genetic disorder, it's pretty easy for even the layman to see how this could be relevant in the future to more prominent diseases like HIV or Alzheimer's disease, Parkinson's, and other major disorders that are more common and more prevalent.
Mm-hmm. They're talking about using it to treat any kind of cancer that has a genetic component to it. So it's huge in what it can do.
Potentially.
But there's also some things that if you extrapolate out a little bit, that it can do even more, right? So we're going to talk about some basic...
awesome ways that this could go terribly wrong.
Right. So the first one, and I think the easiest one to do, is actually immortality or a fountain of youth. So when your body, your cells reproduce, right, and there's this thing at the end of your DNA called a telomere, and every time your cell reproduces, it gets a little bit shorter and a little bit shorter, and that's actually what causes your body to age because the cells aren't reproduced as exact perfect copies anymore, right? They actually have, I believe if I remember correctly, they've done it in mice where they've injected the mice with it and caused it to lengthen the telomeres, thereby reducing the age of the mice. So when the cells in the mice reproduced again, they produced a younger version of that cell, which is incredible. Like, that's just mind-boggling to think that you could have, Papaw sitting there in a wheelchair, you give him this medicine, I mean, this is a little extreme, obviously, and then next thing you know, he's a strapping young lad like he was in the Navy again, right? Mm-hmm. At the same time, if you're already young, or you've already gone through the process, you could just continue to get this medicine or this injection, and it would keep you forever young, essentially, right? You could be at the physical peak of what you would be of your body, right? And your mind would continue to
Learn, develop.
Yeah. So you
would be wizened beyond your appearing age.
So in terms of when you think of all these movies or games that have vampires in them and they're wise beyond their years and so conniving because they have all this experience, it's sort of like the exact same thing, except you're still immortal and you're still a person. So you have all this wisdom and experience of being hundreds of years old, and you're at your physical peak.
Be the exact same thing if you would simply replace your Cain mythology with a CRISPR mythology. Look. Oh, the unintended consequence of CRISPR, vampirism.
Yeah, you're not actually generation 1, you're patient 0. Cain is not verse gen, he's patient 0. That's actually pretty cool. So that's an easy one right there to kind of extrapolate out and what that would mean. And that if you wanted to pull this into, most of these are kind of going to go into a sci-fi-ish kind of a world or a cyberpunk kind of a world, right? So in a cyberpunk, I see it being this... Well, class warfare is a big part of cyberpunk, right? You have this large amount of poor and then this upper crust of incredibly rich. Now, obviously, the poor folks can't afford that.
Hold on. One of the things we're going to talk about with CRISPR is the ability to change things that are not necessary for prevention of disease or for longevity. Okay, so now you're talking about maybe the idea that people are more likely to get promoted if they're a little bit taller.
Right.
Or if they have a nice square jawline or what have you, if they look good, basically. And so now you can change things that are not relevant to your immediate survival. So I can decide, maybe I wanted to actually be 5'9" instead of 5'4", and I'm going to use CRISPR to change those things.
Right.
But you're always going to be limited in all things by money. And so then that segues into your
right. And the thing that's interesting about this is this isn't that far off because China right now is actually experimenting with CRISPR on non-viable embryos, and they're doing that publicly. So God only knows if you want to go down the conspiracy rabbit hole of what they, what anyone anywhere could be doing, because the technology in and of itself isn't that expensive. I believe it went down from 80,000 per experiment to 8,000 in the course of a couple years. So it's just amazing what's happening with this right now. Now, you mentioned the changes in what you can afford, right? So in your cyberpunk world or even your sci-fi world, if you can afford this CRISPR medicine, essentially, you can live forever, whereas all these street rats and poor people, they can't. So they're going to be, laboring under the regular confines of mortality and their physical limitations. Whereas if you can afford it, you can be
your sci-fi branded Methuselah.
Right. Yeah, well, that, and you could be, the equivalent of an Albert Einstein who is physically an Olympic athlete, which is a crazy combination. We talked about a couple episodes ago about what happened if you put Einstein's brain in Frankenstein's body. That's actually exactly what we're talking about now in a completely different way.
Right. I think the cyberpunk one is a good way to look at issues of abuse of something as well, because it kind of has that seedy sort of futuristic drug addiction undertone as well. And there's an interesting short story by Neil Gaiman in his book Smoke and Mirrors, and the story is called Changes. Hold on, let me look. I don't want to get it wrong. It's all of Changes. It's all of 10 pages long. And it's a story of how a man has come up with a cure for cancer, but that cure has the unintended consequence of changing the person's gender. And so now all of a sudden they have this high demand drug where people are wanting to be a different gender, and some are just, maybe for a night. So now I'm deciding what I'm going to wear for the evening, and I'm also deciding whether I'm going to be male or female when I go out for the evening, and what kind of experience I want to have that particular night. And things spiral out of control from there. So it's an interesting story about that I think would fit into the cyberpunk world, but it's also a very good example of how a very innocent invention for the good of humanity has an unintended consequence that suddenly launches you off on this tangent, and things go terribly, terribly wrong.
All right, so after immortality and the Fountain of Youth process, I think you immediately come to, at least my mind comes to like the Ubermensch, the super soldier, right?
Right.
So you have, and this all kind of combines, I think it kind of combines three things into one. So you have super soldiers who are, like I said, the physically imposing. They are at the peak of what our physicality as a human being is capable of genetically without any mechanical modifications, right?
Captain America
Right.
is the easiest example to
Yes,
point to there.
absolutely. At the same time, you have your super genius level intelligence of what we are physically capable of in terms of how smart a person can be. So along with that, I guess you might point to Tony Stark's ingenuity, anybody along those lines, Albert Einstein, these, Nikola Tesla, all these kind of people.
And then what if you could manufacture that?
Right. And then if you want to go down the MK Ultra rabbit hole for your Conspiracy X games, where you have the potential of psychic powers that exist, or even if there's a small amount of psychic powers that the average human exists, what if we can turn on every single gene that makes you psychic? And now you might have been a 1 in a billion possibility genetically to have this thing happen, but now we can just genetically engineer you and produce you in a lab.
You see this in Firefly as well. You see River Tam and the institute that messes with her brain. And
right. Well, that's the interesting thing, is she's born that way, but what if they could just produce her? And, now...
Well, she's born that way being brilliant,
right,
but they dial up her physical and mental traits along with changing a myriad of other things, like a conditioning sort of process, I suppose.
I mean, and I don't think there's a whole lot of need to go into making super soldiers or super geniuses or psychic superpowers. I think everybody kind of already, knows where that comes from, knows how to work those powers into a game. But it is an interesting way to have a different source of those powers. Whereas maybe you're looking for characters or people that were born on a certain day, under certain conditions, to certain families. Maybe now it's just we can just take anybody. We have an orphanage and we just inject them all with CRISPR. And now the government has a whole army of psychic warriors because they just gave them this medicine, essentially, right?
Yeah. And I think that you could use this in Dust Tactics. I realize that that's a lower science world, but it is a world that has an understanding of genetics and genetic processes. Mm-hmm. And you're already talking about a fantasy steampunk sort of setting. So I don't think it's that much more out of the realm of possibility to dial it up just another notch and make that a reality.
You've already made some concessions. Plus that, specifically in Dust, there's some alien technology that exists with the Vril and whatnot, so it's not too much of a leap. If you want to go into that alternate history World War II world, it's really easy to incorporate that, and it fits very well with the mythos of the Ubermensch and everything else, like I said before.
And the other natural example that we come to is the Warhammer 40K universe. Mm-hmm. So you're already talking about Space Marines carrying this gene seed, and it's something to be protected. So what if the other side develops some sort of CRISPR technology that's capable of stealing that DNA information and utilizing it for the negative?
No, I'll go the exact opposite way. So when a Marine dies, he goes down. There's an apothecary on the battlefield that goes to harvest his gene seed so they can take it back to their homeworld to create a new Marine, right? Mm-hmm. But what happens if, in the process of fighting, they deal with some gangers or some heretics from the tech god, the priest of Mars, right? Mm-hmm. And they inject this Marine with CRISPR, and his gene seed is then corrupted, and they take that gene seed back to the homeworld, and the potential that it might corrupt an entire legion of Marines, and not in a chaos kind of a way, in a entirely different way. Because in 40K, it's all about chaos versus the Empire, or orcs versus the Empire, right? And falling to chaos and resisting chaos and serving the Emperor. But what if we have this whole third thing that happens now, and now these Marines are born different because they've been genetically altered? So they still have all the elements and the history of a Space Marine chapter, but now you've twisted it on its head a little and turned it on its head a little bit, in that now they're not full on Chaos Marines because they're not corrupted that way. They're changed in a different way, right?
And there you've got a very interesting plot seed. If instead of running a Space Marine or a typical Dark Heresy 40K go smash 'em game, now you can run in Inquisitor game instead. Well, and you're investigating that, and that's sort of your starting point. Why is this happening? Where did it come from? And how do we stop it?
Yeah, because that would be a huge problem in the 40K universe. If, for those of you that aren't familiar with it, like the Space Marines are sort of like the unbelievably powerful shock troops of the world that sort of keep all the aliens at bay. So, and you could apply that same logic to any kind of fighting force or super soldier that exists out there, in mutating them and changing them and making them kind of independent, whereas before they were unbelievably devoted to their cause and to their country and their principles or whatever. We focus mostly on editing people at this point, but I think it's easy. It would be terrible of us not to mention editing diseases and making superflus and superbugs. So you could very easily use this as a source of your zombie apocalypse. And lots of people talk about, oh, the zombie apocalypse could never happen or couldn't do this. But with this CRISPR technology, you very easily could have a 28 days later scenario. You could very easily manufacture any number of these zombie apocalypses, right?
Right.
Or if you don't want to go the zombie route, you just have some run-of-the-mill apocalypse, which kills off loads of people. It's just as easy that they engineered a super smallpox, and it got out of the lab because mistakes were made. We're human, and that's what happens.
This story is basically exactly what happens in the Firefly universe.
Right.
Where you're trying to control the populace to make them more calm and more manageable. But then in a certain percentage of people, something goes wrong, and now you have reverse. And spiral that a little farther out of control, and you get your zombie apocalypse story because they're just mindless, ravaging cannibals, basically.
Right. The final one that I have noted down here is urban fantasy. Now, in worlds like Shadowrun and Rifts, the elves and dwarves and orcs and trolls come from a mystical thing that happens, a supernatural occurrence, and a warp stone comes, or there's a rift that opens and it mutates people, right? What if it's just as simple as rogue engineering, this technology in the future, and as it goes on, I mentioned how much cheaper it is now versus what it was when it first started. Who's to say that there couldn't be some street doc out there that's doing this and then inadvertently creates orcs and trolls, and then maybe the super rich want to be prettier and more graceful and beautiful, and they turn themselves essentially into elves.
Yeah, I like it as starting out as an actual physically apparent manifestation of abuse.
Mm-hmm.
So it starts out, like you said, you have all these wealthy people abusing this CRISPR drug that's been created now, and they start to look more and more like these elves. And maybe that's how it started, but now it's so many years in the future
right.
that it's just become an established race now.
Right. Well, that's the thing is, it's part of the ethical dilemma with it. Once you edit those genes, if you have a child, those genes will be passed on. And it's not the original genes, it's the modified genes now. So if you did modify someone to become a troll or an orc or an elf, their children would be trolls, elves, or orcs.
And you can use this from a horror aspect in that same sort of setting as well. So now you have the forcing genetic engineering on the poor subclass in order to make them physically apparent as a lesser being. So you're manufacturing trolls as a way of saying these people are no longer human. They are a subhuman race.
Or maybe that's the only way for them to get to a position of wealth. So they start off poor, they join the army, they get developed into these troll-like super soldiers. They spend their, whatever it is, 4, 8, 10, 12-year enlistment. And then if they survive and get out and perform well, maybe they can get medicine to make them back into a human.
So naive. That's something you dangle and never actually do.
Right, that's how
you can never untroll yourself.
That's how you sell that, though, right? And then they bring them back, and then there's always these few people that this is General so and so, and he did so well, Lieutenant Baker or whatever, and all that kind of stuff.
You running man them.
Exactly. Well, I don't know. I feel like this was a little bit rushed, but there's just, it's such a cool technology.
There's a couple things we didn't touch on.
What's that?
So we talked about using CRISPR as a means of data storage and transmission. And I think that's a really cool one because it's easy to see the medical sort of physical engineering side of it. But I've listened to some things where they talk about the limitations of data storage for the sheer amount of data that we're producing now. And DNA sequencing is able to hold a massive amount of information in what is a microscopic amount of space. And so now you have this CRISPR gene capable of lumping off and assimilating a small bit of that data. So imagine basically your carrier pigeons of old, but now they're carrying data transmitted information on DNA sequencing.
Oh, that's super cool. I didn't even think about that as well, because let's say I have the information encoded in my genes, right? But without having the key to get it out, you can't get that information. So not only do you have to have the key, which is me, you have to have the password sort of, which is the specific CRISPR molecule to get that information out of my DNA. And you could do that with people, or you could do it with animals, or any kind of living creature that has DNA to store that data. That's a really cool idea.
There's also a cool plot line. I hate to keep pointing back to Firefly, but it's a sci-fi setting, and I don't know that many sci-fi settings. But in that story, you see the young soldier who's carrying all of these organs for this black market company, and he ends up getting shot, and he was in the war with Malcolm and all that, right? But that part doesn't matter. But the idea that you're carrying encrypted, coded information for an underground black market organization, and how that could get you in trouble if you no longer wanted to carry that, or if you wanted to try and sell it illegally to a third party or something of that nature, then you have sort of the gangster mafia kind of feel to it.
Or what if we do you one better? What if I inject you with it? It makes a benign mutation to your DNA. You don't even know what happened, but you're the carrier of the information unknowingly, transporting whatever this data is across borders, across worlds, across universes, and then someone is there to take it to extrapolate that or extract that information from you. You could just have, like, why does this stuff keep happening to me? Well, little did you know, you got a pinprick and you got injected with this medication that changed your genome in a benign way, not in a massive life-altering kind of a way. And then all the trouble that comes from that, essentially, right?
Right. So the only other thing I feel like we haven't touched on, and we have in various places, is just the unintended consequences that can come from something like this. So we've talked a little bit about the physical engineering and all of that, but and then you just mentioned benign changes. But what if? So for those of you that don't know, when they do medical trials, right? To start with, they usually do some testing on animals, which some people will say is bad, but it's, I think, better in my opinion than testing something you're not sure how it works on human populace, what have you. But when they do initial medical trials, those are done on people who are healthy, because that's a way of sort of limiting the possibilities of things that can happen. So then a lot of times you see medications being recalled in the future because now they're releasing it to the populace at large. It's a much larger sample size, first of all, and you have other people with other conditions who are now taking this medicine who are not healthy, and that changes the way that things work on a microscopic level that's very difficult to anticipate.
Right.
And I think you could easily see the same thing with this. So you're in these stage 1 trials, everything is going swimmingly, you release it to the population at large, and now all of a sudden there are changes that you didn't expect to happen that are starting to happen.
Well, of course, genetic diversity is huge, the amount of different genes that exist in people. So while the people in your trial may be from a certain specific region, and then they don't have any reaction to it, and then you release this medication widespread, and now maybe there's another subpopulation with a certain genetic marker or something, and it turns on bad genes that create them into some kind of...
Even outside of ethnic diversity or gender diversity, the easiest one to point to is either pediatrics, your children, or your pregnant population, because they're almost never involved
in trials,
in medical studies. So maybe you give this to a pregnant lady and it does one thing to her sequencing of DNA, and it does an entirely different thing to the fetuses.
Well,
DNA.
not only that, but you can talk about when you look at blood types, most everyone knows A, B, and O, and then the positive, negative, all three of those. But there are actually more blood types than just those. So when you go outside of the States, you begin to run into these other blood types more commonly. So when you talk about drug trials, those are largely done here in the States. So if you release this medication or someone is affected who is from has a drastically different genetic makeup, the possibilities are limitless, and especially in a gaming universe when you can sort of do whatever you want. But in terms of keeping your world consistent and justifying why things happen or how they happen, that would be, a reason why. And it also could happen here locally in the, like if your game is in the US, right? Because obviously we all share common ancestors, so that maybe your test subjects don't have these markers, but the larger population of the US does. Mm-hmm. So then while it wasn't a problem when we did the trials, we do a larger trial or we release it in a much broader kind of a way, then there's all kinds of trouble that comes from it.
Yeah. And DNA is something that is in every single cell of your body, no matter how small. And I think it would be a cool idea. So maybe you have a small subset of the population that's got this super gene sequencing that the rest of the population doesn't have. Well, what happens if that person is bitten by a mosquito or a spider or a flea, what have you? And now that super special ultra modified DNA is within that creature. And the craziness that can ensue from something like that.
Cross-species contamination, or however you want to say that.
Zoological transmission.
Yeah, is incredible. It's like from human to pig is pretty easy. Human to monkey is pretty easy. But then like the bird flu, like bird to human is a big deal when that happens.
That is the basis for all of the terrible, terrible, just population devastating diseases that have happened.
It's because we have no
your
inherent
bubonic
immunity.
plague, your bird flu, your swine flu, all of those things are diseases that have managed to make a jump from one species of animal to a entirely different species of animal that is not at all prepared to deal with that.
That's why they're so successful in terms of spreading and mortality rates and all this kind of stuff.
And now you're talking about a DNA-based disease as opposed to bacterial or virus. Is something that your body basically has no way of defending against whatsoever. It's kind of like your prion diseases, but even scarier.
Right on. So I think that'll pretty much sum it up for us there. I think we rushed through this one pretty quickly. There's a lot to digest here, but there's a lot of really cool gaming moments I think that you can have. So in terms of genre, I think this idea works better in some than others. Obviously in fantasy it doesn't work, but in sci-fi or horror, it's very easy to put in there. It's very easy to use in a post-apocalypse game. We mentioned like the steampunk or the diesel punk thing. I think it's workable in those situations. And your cyberpunk, obviously, it works very well there. So hopefully this will give these guys some new ideas and some inspiration. As you know, we are members of the Gonna Geek Network, so quick plug for the Pop Culture Cosmos, episode 64. Check out the Pop Culture Cosmos in December on the Gonna Geek Network, as they have guests from all areas of pop culture sharing their thoughts on great holiday gifts and their best of 2017 picks as well. So be sure to listen to the Pop Culture Cosmos channel on the Gonna Geek Network every Monday and Friday as they break down the latest pop culture news and trends and a whole lot more. I think that'll do it for us this week. Hopefully you guys enjoyed this episode. It's something a little different, but me and Lacey are both medical professionals and we get excited about that kind of stuff.
I get excited about any kind of biological science. It's just fascinating.
Right on. So if you guys enjoyed this, please drop us a line and let us know what you thought. At the same time, if you didn't enjoy it, let us know that as well, because I think we might try and make this at least a semi-regular thing where we talk about some new modern medical technologies and how to extrapolate them forward into the future and make them a gameable concept. So let us know what you think. You can hit us up on Twitter at Just One More Fix, or you can hit us up on Facebook at our Facebook group. That's a lot to say. Just One More Fix podcast. It's all linked at justonemorefix.com. You can also support us by joining us on Patreon at patreon.com/justonemorefix. And as always, we will see you guys next week. Thanks for listening. This has been another episode of Just One More Fix. Music has been provided by Kevin MacLeod. You can find him at incompetech.com. You can find us at justonemorefix.com and follow us on Twitter at justonemorefix.